What if space isn't empty at all, but an ocean so vast that entire galaxies are just islands floating on its surface? Welcome to Information World. For centuries, we have imagined space as a silent vacuum, a cold, empty stage where stars simply hang in darkness. But what if that picture is incomplete? What if space behaves less like emptiness, and more like an ocean? Let's start with something surprising. Space is not truly empty. Even in the darkest regions between galaxies, there are particles, radiation, magnetic fields, and quantum fluctuations constantly moving. It may look like nothing, but physically, it's alive with activity. Just like the ocean appears calm from above, while underneath it is filled with currents, pressure, and motion. Think about waves. In the ocean, waves travel across water. In space, waves travel through space-time itself. Gravitational waves, first directly detected in 2015, ripple across the universe when massive objects like black holes collide. These ripples stretch and compress space-time, just like waves distort the surface of water. The universe literally moves. Now imagine currents. In Earth's oceans, currents transport heat and nutrients across the planet. In space, we have cosmic currents, two streams of charged particles flowing through magnetic fields, solar winds pushing outward from stars, and enormous plasma jets erupting from black holes. The universe is not static. It flows. If space is an ocean, then galaxies may be like floating continents. They drift through this cosmic sea, pulled by gravity, influenced by invisible forces. In fact, astronomers have discovered something called the Great Attractor, a mysterious gravitational region pulling entire clusters of galaxies toward it. It's like a massive whirlpool in the cosmic ocean. And then there's dark matter. We cannot see it directly, but we know it's there because galaxies rotate too fast to be held together by visible matter alone. Dark matter acts like an unseen current or deep pressure system beneath the surface, shaping the movement of everything above it. It's as if most of the ocean's mass lies hidden in its depths. But the ocean analogy becomes even more fascinating when we look at space-time itself. According to Einstein's theory of general relativity, space is not a rigid stage. It bends and curves in the presence of mass and energy. Imagine placing a heavy object on a stretched sheet. It creates a dip. Now imagine that sheet is not flat but fluid, dynamic, constantly shifting. Massive objects like stars and planets create currents in space-time, and smaller objects move along those curves. Black holes, in this analogy, are cosmic whirlpools. When matter gets too close, it spirals inward, unable to escape. The event horizon is like the edge of a maelstrom. Cross it, and you are pulled into the unknown depths. Even light behaves as if it is moving through a medium. It bends around massive objects, slows down in gravitational fields, and shifts in energy as it climbs out of gravitational wells. It's almost like light is navigating a changing sea rather than crossing empty void. But here's where things become even deeper. On the smallest scales, quantum physics tells us that space is not smooth. It's filled with tiny fluctuations, virtual particles appearing and disappearing constantly. This quantum foam suggests that at extremely small scales, space-time is turbulent. Not calm. Not flat. But frothy and restless. Picture the surface of the ocean during a storm: chaotic, unpredictable. Now imagine that same turbulence at a scale smaller than atoms. That might be the true nature of space. And what about expansion? The universe is expanding. Galaxies are moving away from each other, not because they are swimming outward, but because space itself is stretching. It's as if the ocean is growing larger every second, carrying the islands with it. This expansion is accelerating due to something we call dark energy, a mysterious force pushing the universe apart. If space is an ocean, then dark energy may be like a deep pressure building from within, causing the sea to swell. This analogy also changes how we think about exploration. When sailors first explored Earth's oceans, they thought they were traveling across the edge of the world. They didn't know what was beyond the horizon. Today, we launch spacecraft into what we call outer space, but perhaps we are really sending vessels into a vast cosmic sea. Our probes ride solar winds. Our satellites navigate gravitational currents. Our spacecraft use planetary flybys like slingshots, borrowing energy from massive bodies, almost like catching waves. Maybe in the distant future, humanity will not think of itself as a species that travels through space, but as one that sails it. There's also something poetic here. Oceans on Earth are places of mystery. We have mapped more of Mars than we have of our own ocean floors. The deepest trenches remain largely unexplored. Strange life forms exist under extreme pressure in complete darkness. Now think about the universe. We can observe only a fraction of it. Most of the cosmos is invisible to us. Dark matter and dark energy make up about 95% of everything. It's like standing on a tiny boat, staring at a seemingly endless horizon, knowing that most of the sea is hidden beneath you. The ocean analogy also reminds us of scale. A single drop of water seems small, but combined with others, it forms vast seas. In the universe, atoms form stars, stars form galaxies, galaxies form clusters, and clusters form enormous cosmic webs, filaments stretching across billions of light years. From a distance, these structures resemble a network of interconnected currents. Astronomers even call it the cosmic web. It looks like a three-dimensional ocean of matter, with dense nodes and vast voids like swirling patterns in water. And yet, there is a key difference. Unlike Earth's oceans, space has no edge that we know of. The observable universe has a boundary defined by how far light has traveled since the Big Bang. But beyond that horizon, the cosmic ocean may continue infinitely. Or perhaps it loops back on itself. Or perhaps it is part of something even larger, a multiverse, where our cosmic sea is just one drop among many. The ocean metaphor doesn't just make space poetic. It changes how we imagine reality. Instead of emptiness, we see motion. Instead of silence, we see vibration. Instead of isolation, we see connection. Every atom in your body was forged in the heart of a star. Every star drifts within gravitational tides. Every galaxy participates in the slow dance of expansion. We are not separate from the cosmic ocean. We are waves within it. And waves don't exist independently from the sea. They are temporary shapes in a larger flow. Maybe that is what we are, patterns in space-time, rising and falling for a brief moment in an eternal cosmic tide. So next time you look up at the night sky, don't imagine emptiness. Imagine depth. Imagine currents stretching across billions of light years. Imagine black holes as whirlpools, galaxies as drifting islands, and space-time as a vast, living ocean. The universe may be far stranger and far more fluid than we ever imagined. If this idea expanded your perspective, let me know what you think in the comments. Do you believe space is truly empty, or could it be something much deeper? And if you enjoyed this journey into the cosmic ocean, don't forget to like and subscribe to Information World for more mind-expanding explorations.